Hey friends, so today we look at problem 101 symmetric tree once again. If you remember in the last video, what we did, we actually solved this using the relatively easier method, which was the recursion. And if you haven't seen that previous video, I have included the link in the description, so you can click on that link and go look at that video again. But what I'm doing in this video really is looking at the follow-up, which says solve it both recursively and iteratively. So since we've done the recursive version, let's look at the iterative version for this problem. I'll quickly go through this again in case you've not seen that before. It's given a binary tree. You need to check whether it's a mirror of itself. So what's really the mirror of a binary tree? So the way this problem really expects it to be is if you really draw a line like a mirror right down the center of the tree, the left and the right views should be mirror images of itself. So for example, 2 is the same as 2, 3 and 3, 4 and 4. So in this case, this guy is a valid symmetric tree. So how do we solve this? Similar to the recursive version, this one really what it does is it starts at the root node. We look at the root node, we first do a null check. So if the root is null, then we don't have to do anything else. We either return true or false, depending on what the question expects. I'm going to assume that a null node means that the tree is a mirror of itself, so we just return true. But assuming that it's not null, what we do is, as we do with most BFS problems, to do something iteratively, we usually have a queue. We take a queue and then we add nodes to the queue in an iterative fashion. Then we pop nodes and then we do something with it. So we'll follow a similar BFS pattern here. Since this is not null, we'll create a queue. Let's assume this is our queue, and then we'll add nodes to it. Now, what are the nodes? The nodes are going to be the node.left and the node.right. Now that we've added the two nodes to the queue, we just iteratively go through the queue, pop two nodes at a time. So in this case, we'll take the first node, set it as L, take the second node, set it as R. Now, what do we do with this? If you remember what we did in the previous recursive version as well, we just do three things with each set of nodes. Three things are: first, do a null check; second, do a value check; and third would be, while the queue is not empty, keep adding nodes from these two nodes, pop them two at a time from the queue, and then keep repeating the whole step again, these three steps again. And now remember, since this needs to be looking for kind of a mirror image of each other, you do left left, right right, left right, and right left, and you'll see with the visuals it'll be kind of self-explanatory at that point. So we remove these two nodes, then we do the compare. Since they're same, what we do is we take the left node, right node, we add it to the queue. Then we also take the left.right and right.left nodes and add it to the queue. Then we pop the first two nodes. One becomes L, second becomes R. We do these same steps. Obviously, since there are null nodes, we really don't care about them. We won't be iterating through them. So we look at these two, they're the same. Pop the next two nodes, and they're the same as well. At this point, our queue is empty. All our nodes were either not null, or their values were the same. So iteratively, we're able to go through the entire tree and make sure that it was symmetric. Pretty straightforward if you understand the visualizations and kind of keep these three steps in mind. Very similar actually to the recursive version as well. So let's see if we can quickly look at the algorithm for this. So I've written it already. I'll just probably walk you through this. If you remember, we look at the root node. If it's null, we just return true. Next, we create a queue of tree nodes, add the root left and root right, and then just keep doing a BFS while the queue is not empty. Remember what we did was we removed the two nodes that we just added before, L and R. We do a null check. If both are null, then continue because they're the same. The next step is if one of them is null, or if they're not null but their values are not the same, then we just return false right away. There's no point continuing. But if none of this is true, then we add their child nodes to the queue. But you remember we offer L left, R right, then L right, and R left. If you go through this, the queue becomes empty. That means we've compared each node. At this point, we can just return true. It's pretty straightforward. I would think that if you get this question, you'd probably be asked to kind of code either the recursive or the iterative version, whichever you're comfortable with. But there is a chance that they might ask you to do it in both recursive and iterative. So it's a good idea to be aware of how to do it in both ways. If you haven't already checked out, please do look at my recursive version of the same problem. It has some visuals which should help you explain that as well. Again, this one's pretty popular question asked in most of the FANG interviews, and hopefully this was a helpful video.